All right, welcome to the first day of our new unit. We're in our unit 8C packets. Your homework for tonight is page 3, numbers 1 through 4. So on those, you are going to be graphing some exponential functions. When you graph those, you will need to show a t-table, and I want you to have at least 5 points in your t-table. You can put the equation right in the graphs page and do a control T to get those 5 points. Pick 5 points that are going to fit on the graph. There are grids for you at the back of the packet. It is okay if you do your t-table right next to those grids and plot those. When you plot the graph, make sure to have arrows on your graph, label the x and y axis, and label the equation. In addition to graphing it on the homework, you will have to tell which transformations are occurring. We will be doing the transformations today, so the first packet page 1, will be helpful in doing that part. You can either put the transformations right back with the grids, or if you want to put those on page 3, you can do those as well. But when you upload your homework, I should for each of them see a t-chart. I should see actual points plotted, just not a rough sketch. You should have arrows on your graph, a label on your equation, label on XY axis, and telling the transformations for each. Again, page 1 will help you with that. So we're going to start on page 1 here. So 2 to the x, 3 to the x, and 10 to the x. So here are those 3 graphs. 2 to the x is in blue, 3 to the x is in red, and 10 to the x is in black. So first we want some ways how they are alike. So first thing is they're all exponential functions. Another way they're alike, notice they're all crossing through 0, 1. So they have the same y-intercept of 0, 1. And a third way they're alike is notice they are all exponential growth. They are increasing. So back on page 1 for part A, how are they alike? They are all exponential. All growth. And they all have the y-intercept of 0, 1. And how are they different? Well, they all have different bases, so they all have different growth rates. The 10 to the x is steeper than the 3 to the x, which is steeper than the 2 to the x. So we're going to say different bases / growth rates. Now for part C, our domain and range. Domain is the x's. Notice it goes forever to the left, and it'll keep going up forever to the right. Those will keep increasing, so our domain will be all real numbers. For our ranges, those graphs, they're getting as close as possible to the y-axis without ever hitting it. The calculator, it makes it look like it's getting there, but that's just because the pixels, it gets closer than even the pixels. So we're never actually hitting the y-axis, and we're staying above it. So therefore, our domain is going to be all real numbers. So that's the fancy symbol for all real numbers. You do 2 vertical lines and then make a capital R, or you could just write out in words all real numbers. And then for our range, our y's were always greater than 0. All right, in 2, we're going to compare the graphs of 2 to the x and 1/2 x and ask the same questions. So here's our graph of 2 to the x and 1/2 x. Well, they're both still exponential, and they both still have the y-intercept of 0, 1. But they're not growth anymore, so that would be a difference. And another difference is their bases are different. So for part A, how are they alike? They're both exponential. And their y-intercepts are both 0, 1. How are they different? One of them is growth, the other is decay, and their bases are different as well. Now our domain and range, notice they're still both going forever left and right. So our domain is still all real numbers. And their range, the y's get as close as possible to the x-axis but never hit them, and then go up forever. So the domain and range are actually just going to be the same as what we had in question 1. So our domain will be that all real numbers, and our range will be y is greater than 0. So moving down to 3, this is the part that's going to be a good reference for you on your homework. When you have to tell which transformations are happening, flip back to the bottom of page 1 here and look at question 3, and that will help you out a lot. So here's our graph of 2 to the x and 2 to the x plus 2. How did the graph change when it went to 2 to the x plus 2? Well, hopefully you can see it shifted, and it shifted 2 to the left. So for 3a, we're going to say shift left 2. Here's our next one, 2 to the x with 2 to the x minus 2. Well, if we compare those, notice the blue one is shifted 2 to the right. So in B, we're now going to say shift right 2. Well, notice that's kind of opposite of what you would think. You would think a minus would go left and a plus would go right. So in the exponent, when you have something added or subtracted, it's opposite of what you would think. Here's our next one. Here's 2 to the x and minus 2 to the x. Notice when you negate out front, it flips over the x-axis. So for C, we'll say reflection over the x-axis. Next one, we have 2 to the x plus 3. So here's the original 2 to the x and then 2 to the x plus 3. Each of these are just shifted up 3. And it's a little tough to tell with the curve, but if you go to the table and look at the y values, notice they go from 2 to 5 and from 4 to 7. So they are, in fact, going up 3 for each of those. So in part D, we're going to have shift up 3. Well, 2 to the x with a minus 4 at the end. See if in your head you can make a prediction. Well, there's our 2 to the x, and there's our 2 to the x minus 4. That shifted everything down 4. So for E, we'll have shift down 4. So notice when it's at the end, it's exactly what you would think. You would think a minus should go down and a plus should go up based on how our axes are labeled. So when it's adding on the end, it affects the y's and it does exactly what you would think. But in the exponent, it's opposite of what you'd think. Here's our next one, 3 times 2 to the x. Well, I want to look at the table again. Notice our y values, Notice our y values are 1, 2, 4, and 8. Well, now they're 3, 6, 12, and 24. Notice those are all triple what our original y values were. So there's 2 things we could write for this. You could either write multiply y's by 3. So that's one option of what you could write. Or the y's are our vertical axis, and they're getting bigger, so you could also say vertical stretch by a factor of 3. And that's an either or. Either of those options would be fine. And our last one, 2 to the minus x. You have 2 to the x, that's the one going upwards. 2 to the negative x is going downwards. So notice this is a reflection over the y-axis. So just realize that when the x gets negated, it actually goes over the other axis. So a minus x reflects it over the y-axis. If you negate out front, it reflects it over the x-axis. Again, use the bottom of this page to help you out on the homework when telling your transformations. On the homework, make sure you have a t-table with 5 values. Make sure you plot actual points, have arrows on your graphs, label your XY axis, label your equation, and tell the transformations for each of them. All that can be done right in the grids on the back of the packet, and you're doing page 3, 1 through 4. That's it for this video. Have a great rest of your day.